Hello, my name is John Rees and I'm Chief Scientist for Multi-Hazards and Resilience at the British Geological Survey, BGS. We provide data, information and advice to stakeholders in relation to environmental hazards and associated risks. I want to use this presentation to show how we interact with our government, the UK government, in relation to space weather as an example. Space weather, the transmission of energy and matter across space, usually from the sun, can have major impacts on Earth. There are a range of space weather events, including solar flares and coronal mass ejections. The latter are particularly concerning to us because they have a major impact on ground-based systems through geomagnetically induced currents set up in the Earth, such as you can see on the image on the bottom left, where an event hit several years ago, and also in transmission systems, such as pipelines, signalling systems, and particularly in electrical grids. Space weather events are pretty rare and historically haven't had major impact. But given the technologically advanced nature of society today, we are now highly vulnerable, and there's no doubt a significant event will occur and have major impact on Earth in the future. Recognising the threat posed by space weather, the UK government, through the Cabinet Office, has put space weather on the National Risk Register. This register lists all of the malicious and non-malicious risks that could affect the UK over the next 2 years and recommends how the public should react to them. In the figure, you can see all of the hazards that are threats to the UK, and ringed are those associated with space weather. And you can see that these have moderate to significant impact and a medium to medium high likelihood. So what does BGS do in relation to space weather? Well, firstly, we monitor it. We do this through a collection of 9 observatories spread around the Atlantic region, with 3 in the UK. And there's an aerial picture of one of those in the UK at Hartland Point in Devon, shown below the map. We also take point measurements of vulnerable sites, and we measure the currents, the geomagnetically induced currents in pipelines and particularly electrical grids. Secondly, we generate forecasts. We do this using our own measurements, but we integrate these with data from other sources, such as from NOAA in the States and from other observing systems around the planet. We provide daily forecasts to stakeholders primarily in the UK through the BGS website, emails and Twitter. And you can see here a range of the outputs you can see on those sites. And we do this very much in conjunction with the UK Met Office and again NOAA, to make sure that we have some consistency in the forecasting we're producing. Thirdly, we provide specialist services. We do this with the UK power transmission systems and particularly for the national grid. You can see on the right a map of the grid showing where we are concerned about. We provide data, indices, forecasts, information, expertise also to the European Space Agency's Geomagnetic Expert Service Centre and Space Weather Portal. Finally, we respond to space weather events when they occur as part of the consistent communication protocol. We also undertake a lot of research on space weather, and what's shown on this slide are a few examples of programs that we're currently involved in. One's called Swimmer, which is building an operational ground effects forecast for the UK using existing research and knowledge. And you can see a map from that exercise. I've got to say that Northern Britain is particularly vulnerable to space weather events. We have a project called Euphoria, which is modelling the full Sun-to-Earth chain of space weather impacts for Europe. SWIGS, studying the impact of space weather on ground-based technologies in particular. And then we do international work, such as a program called Solar Tsunamis, which we're undertaking in New Zealand with the New Zealand government. On the right-hand side, you can see also an image showing where we've actually put more variometers into the UK system, so we can detect the impacts of solar weather events when they occur. BGS is also part of a group called SIEGE, that stands for the Space Environment Impacts Expert Group, which comprises several government institutions and elements of industry who have major interests in space weather. You can see that BGS is here as a government institute, a scientific institute, along with others like it, including the British Antarctic Survey, but then we also have operators and government departments. One of the great things about SIEGE is we collectively have been able to work out what we would likely do in the case of a space weather event in the future. We've done this through playing games and working out scenarios in relation to future events, so that when an event does occur, we will be in a much better position as a country to minimise the negative impacts. We also ensure that space weather is regarded as a threat by people in government and in institutions who are affected by natural hazards more broadly. We do this largely through the Natural Hazard Partnership, which is a collection of many governmental and scientific institutions which provide forecasts on a daily basis across many hazards. And in the earth hazards, we also deliver information and advice in relation to earthquakes, landslides, subsidence, volcanic eruptions, groundwater flooding and tsunamis. In doing so, we ensure that space weather can be considered as part of this wider portfolio of threats that the UK needs to handle on a daily and weekly basis. In this short presentation, I've given you a snapshot about how BGS provides data, information and advice to government and wider stakeholders in relation to just one hazard. If you have any questions about what we do in relation to space weather, or how we work as a geological survey to provide information and services across government, I'll be very happy to answer your questions at any time. You can contact me via the email shown below. Thanks very much for listening.